Hello dear students, this is your mathematics teacher Miss Damini Riyang, and I'm here today with the rest of your exercise questions of exercise 8.1 of chapter number 1 entitled Real Numbers. Sub-question 2 of question number 1 says, use Euclid's division algorithm to find HCF of 196 and 38220. Here 38220 is the bigger number and 196 is the smaller number. Therefore, 38220 is the dividend and 196 is the divisor. So 38220 will be divided by 196. So 196 into 195 gives 38220 and the remainder is 0. So as usual, when the remainder is 0, we don't need to proceed the division any longer. So therefore 38220 equals to 196 into 195 plus 0. So we know that according to Euclid's algorithm theorem, A equals to B into Q plus R, where A is the dividend, B is the divisor, Q is the quotient which is 195, and here R is the remainder. For sub-question 3 of question number 1, we have to find the HCF by using Euclid's algorithm theorem of 867 and 225. Here 867 is the bigger number, therefore it is the dividend, and 225 is the smaller number, therefore it is the divisor. So 225 will divide 867. 225 into 3 gives 675, and when you subtract it, the answer comes as 102. So now 102 will be the divisor and 225 will be the dividend. So therefore 102 into 2 gives 204, and when you subtract 204 from 225, you get the answer as 51. Now 51 becomes the divisor and 102 becomes the dividend. So 51 into 2 gives 102 and the remainder is 0. So therefore HCF of 867 and 225 is 51. The answer here will be 51 because 51 when divided by 2 gives a remainder as 0. So writing them in the format of Euclid's division algorithm, A equals to BQ plus R. Here A is the dividend which is 867 and B is the divisor which is 225. So 225 into 3 which is Q plus R, that is the remainder 102. In the next line, we will write 225 as the dividend and the divisor is 102 into 2 plus the remainder here is 51. The next line we will write 102, which is the dividend, is equal to 51 into 2 plus the remainder. The remainder here is 0. Since the remainder is 0, we don't need to continue it further, and this is your answer. Question number 2 says, show that any positive odd integer is of the form 6q plus 1, 6q plus 3 or 6q plus 5 where q is some integer. So the solution is like, first write let A be any positive integer and B equals to 6. Now why B equals to 6? See, we have 6q plus 1 here, 1. So, and according to Euclid's division algorithm, A equals to BQ plus R. So here B equals to 6, Q is Q, and R equals to 1. So therefore B equals to 6. In the next line we will write, then by Euclid's division algorithm, A equals to 6q plus R. For some integer q is greater than or equals to 0 and R equals to 0, 1, 2, 3, 4, 5. Why only up to 5? It is because B is equal to 6 and R should lie between 0 and B, and the value of B is 6. So the value of R will be 0 to 5 only. Next we will write if R equals to 0. We will put the value of R as 0. Then A equals to 6Q plus R, and A equals to 6Q plus R equals to 0. So A equals to 6Q. Next we put R equals to 1. A is equal to 6Q plus R. So 6Q plus the value of R here is 1. So 6Q plus 1. So your ultimate answer is 6Q plus 1. So when we put R equals to 0, 1, 2, 3, 4, 5, we get the value of A as 6Q. Next is 6Q plus 1, 6Q plus 2, 6Q plus 3, 6Q plus 4, and 6Q plus 5. So we can write that when A is equals to 6Q plus 2, 6Q plus 4, A is an even number which means 2 and 4. But when A equals to 6Q plus 1, 6Q plus 3, 6Q plus 5, A is an odd number. So we can conclude that any positive integer is of the form 6Q plus 1, 6Q plus 3, 6Q plus 5, where Q is some odd integer. That's what we had to prove in the question. Your question number 3 says, an army contingent of 616 members is to march behind an army band of 32 members in a parade. The two groups are to march in the same number of columns. What is the maximum number of columns in which they can march? So to find out the maximum number of columns in which they can march, we have to find the HCF of the numbers of these two numbers. So let us find out the HCF of 616 and 32. Here 616 is the dividend because it is the bigger number, and 32 is the divisor because it is the smaller number. So when we divide 32 and 616, we get 32 into 19, which is 608, and the remainder is 8. So now 8 will divide 32, which will now become the dividend. So 8 into 4 gives 32, and the remainder is 0. Now representing this in the form of Euclid's division algorithm, we can write this as HCF of 616, 32 equals to 616 which is A equals to 32 which is B, and Q will be 19 here, plus 18. 18 is the 8 is the remainder here. Next we will write 32, which now becomes the dividend, equals to 8 into 4. Q here is 4 plus 0. The remainder here is 0. So your answer is 8, and therefore you can write the maximum number of columns in which they can merge is 8, since your HCF is 8, which is your answer. So that's all for today's class. For question number 4 and 5, use the same method which we used in question number 2. Just square it for question number 4, and for question number 5, just cube it. In our next class, we will be solving the rest of the exercise questions. Till then, take care and bye-bye.